Now that we've learned about arithmetic series, it would only make sense to learn about geometric series. So that's what we're going to be doing in this set of notes. Now, a geometric series is, if you remember geometric, you have a bunch of terms and they're separated by a common ratio. It's being multiplied by the same number every single time. And if you remember, the difference between a sequence and a series, you're just adding them together. So a series means take all those numbers and add them up. So that's all we're going to be doing in this set of notes. And it's a very formulaic approach to it. So let's take a look at the formula for it. In the IB formula booklet, they're going to give you this formula, so please don't waste your brain power memorizing it. But the formula for the sum of a geometric series is S sub n, that's the sum of the first n terms, is equal to u sub 1, that's the first term, times your common ratio to the nth power, subtract 1, over r minus 1. And there's the formula. Now, they're also going to give you one other derivation of this formula, and it's essentially the same thing. And if you use this one, you'll get the exact same answer. But I'm just going to show you the other one. It's S sub n equals u sub 1 times 1 minus r to the n over 1 minus r. And you might be wondering, well, why do we have these two formulas? I don't know. But sometimes it's easier to use one of them compared to the other. Typically, you're going to want to make the denominator positive, and that makes it easier to evaluate. But essentially, it's the same thing, so it doesn't really matter. Now, there is a professor that's on YouTube, and he does a great job of explaining the proof behind how you get these formulas. So I kind of showed you the proof for arithmetic series in the last video. I don't have time to mix that all in. It's a little more complicated proof as to why these formulas come out the way they do, and he's probably like 10,000 times the teacher I am, because he has a really cool Australian accent. So go ahead and check out that link if you are interested in how these formulas are derived. All right, let's move to the first example, where it says to calculate the sum of the first 12 terms of this series. So if we look at 1, then 3, then 9, it's not arithmetic because it's going up by 2, then 6, and so on. It's geometric because it is multiplying by 3 each time. So this is geometric, and to find the sum of a geometric series, we're going to use these formulas up here. Now, since the common ratio is a 3, you'll notice if you put in a 3 down here, 3 minus 1, that's a positive number. That's going to be a good thing. If you plug in a 3 here, 1 minus 3, that's a negative number, not as fun to deal with. So I would just pick this first formula here to approach this problem. So to find the sum of the first 12 terms, all we have to do is take u sub 1, that's the first term, which is a 1, times your common ratio, which is a 3, raised to the nth power, we have 12 terms, subtract 1, all over 3 minus 1. And all we have to do is evaluate and simplify. So I think it's easiest if you just evaluate the top part separately and then the bottom part separately and then divide them at the end. Otherwise, you need to remember to put parentheses down here, and sometimes we forget that. So if you evaluate the top part, you end up with 531,440. And if you evaluate the bottom part separately, hope you don't need a calculator for that one. 3 minus 1 is 2. And then you can divide them, and we get a final answer of 265,720. So if you were to find the first 12 terms there and added them all together, that's what you get. So go ahead and try the next one on your own. In this case, the common ratio is going to be a negative number, so you're probably going to want to use this second formula just because it makes the denominator negative. Another key point here, just make sure you use a parentheses around the common ratio because that gets kind of important at that step. So make sure you're careful with evaluating that. When you are all done, come on back for the next example. So this next example, it says we have this series. It starts at 8,192. Then we're adding 6,144, and so on until the last number of this series is 1,458. We don't know how many terms are in this series. So first off, let's recognize why it's geometric. If we take the second term divided by the first one, if you take 6144 and divide it by 8192, you get 0.75. Let's double check it for the third and second terms. If you divide these, you get 0.75. So it is a geometric series. Now, to find the number of terms in a geometric sequence, we can use the formula that we had previously. So we take u sub n, that's 1458, is equal to the first term, 8192, times your common ratio, 0.75, to the n minus 1 power. Hopefully you didn't forget that formula. Now if I'm trying to solve for the number of terms here, then we're trying to solve for n. Let's get rid of that 8192. We'll divide by 8192. And I'm going to get rid of that. Now you're going to realize that we have this 0.75 in the way. It's a base. So our variable is an exponent, and it has a base of 0.75. And remember, to get rid of that base, we can, I'm going to kind of write it here, we can log with a base of 0.75. So I'm going to write log with a base 0.75 of that, whatever that decimal was. And so what we're going to do is we're going to type log. You can use the base 0.75 on Desmos of that fraction. And if you do that, you're going to end up with 6. Another way that you could have typed this in to Desmos is you could have done log of that whole fraction, 1458 over 8192, divided by log of 0.75. So if you didn't have Desmos available, you could use it with a graphing calculator. So we get 6 equals n minus 1, which then becomes n equals 7. Then it says to calculate the sum of these terms. So now that I know that there are 7 terms in this series, we want to find the sum. So since the common ratio is 0.75, I'm going to use this formula here. So it's going to be the sum of the first 7 terms is equal to our first term, u sub 1, and in this case it is 8192. And then we multiply it by 1 minus your common ratio, 0.75 to the 7th power, over 1 minus 0.75. And then let's just go ahead and go to Desmos. We have 8192 times 1 minus 0.75 to the 7th. So the top of that fraction becomes 7098.5. So we get 7098.5. And on the bottom, 1 take away 0.75 is 0.25. Now if you're dividing by a fourth, a quarter like that, you're doing the same thing as multiplying by 4. So I'm going to go to Desmos, and we are just going to multiply that by 4 to get our final answer. And that's 28,394. So 28,394 is the sum of the first 7 terms. So the tricky part there was we first had to find how many terms there were, and then we were able to plug it into the formula. So there is one for you to do as practice on your own. You've got that geometric series. First, find how many terms there are. That should be a review from our last unit or last assignment. and then calculate the sum. When you are all done, come on back for the last one. Okay, on to the last example. We have this geometric series and it might look a little bit more scary. Don't be scared by these square roots. So we got 3 root 2, 6, and 6 root 2. It's geometric, and let's show why it's geometric. If we divide these, if I take 3 root 2 and I divide it by 3, your common ratio is just root 2. It's multiplying by a square root of 2 every single time. We're starting at 3. That's your first term. If you multiply this by root 2, it just becomes 3 root 2. Now for this third term, here's where it becomes a little bit different. If we take that 3 root 2 and multiply it by another root 2, this square root of 2 times the square root of 2 is the square root of 4, which is just 2. So it becomes 3 times 2, which is 6. And that's why you see the third term is a 6. And then it gets multiplied by yet again another root 2. So your common ratio in this case is the square root of 2. That's the first part of this. And now it's saying determine the smallest value of n. So how many terms would you need to make the sum greater than 500? So let's go ahead and use this first formula here, because the square root of 2 is like a 1.41 or something like that. So we're going to use that first formula. And we have the first term is a 3 times your common ratio. That's a root 2 to the nth power. We don't know what n is. Subtract 1 over root 2 minus 1. And whatever that evaluates to, it has to be greater than 500. So we're saying that that sum, here's the sum, that's the formula for the sum, has to be greater than 500. Now to solve this, what I would do is I would start by multiplying both sides by root 2 minus 1. And if you multiply by a root 2 minus 1 over here, those cancel out. You'll get that decimal on Desmos. Then I would divide both sides by 3, divide both sides by 3, and that goes away. So let's go ahead and type this into Desmos first. So we get root 2 to the n minus 1 greater than, we'll go to Desmos, and we have 500 times the square root of 2 raised to the power of nothing, I think. Nothing. Subtract 1. Subtract 1. Get rid of that guy. And then all of that has to get divided by 3. So that becomes 69.0355. So let's round that one. In this case, the rounding won't matter so much because we're not finding an exact value. So we get 69.036. Now let's add 1 to both sides. So we get root 2 to the n greater than 70.036. And lastly, once again, we have to log this. So we're going to do log base root 2 of root 2 to the n greater than log base root 2 of 70.036. And by doing that, this all cancels out. And we get n is greater than, I'm going to type in functions. We have log of, it was 70.036. And I'm going to divide it by log of the square root of 2. And we get 12.26. So n is greater than 12.26. If n has to be bigger than that, we're going to say n is 13. And that's it for this set of notes. Thanks for watching.